All right, so the goal of this problem is to go and solve the linear system using the eigenvector method. And the first step of this is always to go through and find our eigenvectors. So the first thing we want to do is take the determinant of a minus lambda I, and we set this determinant equal to 0 to find our eigenvalues. And that's going to be the determinant of our matrix A, which is 5, 3, -6, -4, minus lambda times the 2 by 2 identity matrix, which is just ones on the main diagonal and zeros everywhere else. And we're taking that determinant and we're setting it equal to 0. And when we simplify this down, we'll multiply the lambda into the identity matrix. So this is the determinant of 5, 3, -6, -4, minus the matrix with lambda on the main diagonal and zeros everywhere else. And remember now, when we subtract our matrices, we just subtract entry-wise. So this is the determinant of 5 minus lambda, 3, -6, and -4 minus lambda. And shorthand for determinants is using the vertical absolute value bars. So that's just 5 minus lambda, 3, -6, -4 minus lambda. And because this is a 2 by 2 determinant, we can just do our multiplication method. So that's just 5 minus lambda times our -4 minus lambda, the forwards diagonal, minus the product of the backwards diagonal, which will be plus 18. Multiplying this out, we have -20 minus 5 lambda plus 4 lambda plus lambda squared plus 18 is equal to 0. Simplifies down to lambda squared minus lambda minus 2 equals 0. We can now factor this as lambda minus 2 times lambda plus 1 equals 0. So our first eigenvalue is lambda 1 equals -1. And the second eigenvalue is lambda 2 equals +2. And then in the next step of the problem, we'll go and now find the corresponding eigenvectors for these two eigenvalues.